In this lesson, we're going to talk about symmetry for 4.6. Symmetry exists a rigid motion, reflection, translation, rotation, or glide reflection that maps the figure onto itself. Figure has symmetry, are self-congruent. One type of symmetry is line symmetry, and you can see that line here where we kind of put the line in there and it divides the figure kind of into that reflection or reflectional symmetry, and it matches up. So we're going to determine if these have line symmetry. So if we were to kind of draw a line this way, would it match up? No. If we were to draw a line this way, would it fold down onto that one? And no, because this point here is kind of longer, so it would be up here, and this point kind of would be right in here. So it would not kind of match up. So this one does not have line symmetry. This one does have line symmetry, so we're going to go ahead and draw the lines. There's one that way, there's one horizontally, and then we want to look diagonally. I can go through kind of the vertex points, if I can actually go through the vertex points. Whoa, it's hard to do. You need a straight edge. I obviously don't have one. So through each of those vertex points, and then can we go through this way? Yes, we can. So we have 1, 2, 3, 4, 5, 6 lines, because this number 1, this is number 1's line coming through down here. This is number 2's line. So we only have 6 lines only. We have 6 lines. That's quite a bit, actually. All right, rotational symmetry or radial symmetry maps onto itself being rotated less than 36 degrees. So if we go all the way around 36 and get back to our figure, that does not have rotational symmetry. It has to match up less than 36. So the number of times that that figure maps onto itself within that 360 degrees is called the order. Order is kind of our number of times. And we can find what's called the magnitude or degree or angle by taking 360, dividing it by the number of times that it maps onto itself, and that's the degrees. So some figures have both line and rotational, and a figure has a point of symmetry if the figure can be mapped onto itself like rotationally at 180, then it has point symmetry. So if it goes and matches up here at 180, then it has point symmetry. All right, so let's go ahead and take a look at a couple of examples. And I'm going to come and jump over here to Word so I can actually rotate them visually for you. So if we were to rotate this one, actually I'm going to move my pictures down, sorry, because those are going to start to change those, and then it's hard to visualize. So let me get those kind of out of the way. Okay, so we're going to go ahead and rotate it, and it is going to be the same, thinking kind of our star. It is rotating, and it is the same if we kind of rotate it around. We can still see that star kind of in the same way. So this does have rotational symmetry. And the next one, our card. Let's take a look at that one. So if I go this way, no. But if I go this way, yes. Whoop, maybe. There we go. So 180 degrees, it is the same. And then I get back to, nope, not 270, but yes, back to 360, of course. So it does have rotational symmetry, barely. And then our last one. Let's take a look at this kind of crazy looking, I think it's a game. No. And then that is not the same because those 3 dots were at the bottom before. So this, all this stuff inside here, it would have to look exactly like that, and it does not because those 3 dots are at the top. So this does not have rotational symmetry. So no rotational symmetry. All right, so we're going to go ahead now on our last 4 examples here and kind of identify all of those parts, line, rotational, and then do our order and magnitude we kind of talked about on the previous page. So this, does it have rotational symmetry. So that is our first question, is could you rotate this? And since it is a pentagon, no matter how you rotate it, it's still got all those 5 sides. These are all the same. So yes, if I were to just rotate it, and the order, so I could have this point be coming here, so that's 1, and then 2, and then 3, and then 4, and then 5. So it would map itself 5 times. So I would take 360 divided by 5 to figure out the degrees, which would be 72 degrees. And then line symmetry, if I drew a line kind of in all of its different parts, would it be symmetrical? And yes. Point symmetry, remember, it has that 180 degree rotational symmetry, which on this one, it actually does not have 180 degrees because it doesn't go directly there. And so on this one, there is no rotational symmetry because all the sides are different. So no matter how I rotate it, I have to go all the way 360. So no. So we don't have any order or magnitude. Let's check line though, because it could have no rotational but still have line. So not that way, not that way, not that way. No. No line. And so no point if it doesn't have the 180 rotational. All right, this one, again, you can kind of double check maybe with patty paper since you don't have word to kind of turn it around. But if I were to be unsure, I would use either my patty paper or some way to help me rotate it. Oop. It's kind of... So there's 180, almost. So it's not 90. And then if I go to 180, if it will like me, there we go. There is, ooh, goodness, almost there. Well, it's not liking me, but 180 is going to be that same image. So it does have rotational. It does have an order of 2. So it'd be 180 and then back to 360. So 360 divided by 2 is 180 degrees magnitude or angle. And line symmetry, no line symmetry, but it does have that point symmetry because it's got the 180. And then this one, yes, that would definitely have rotational symmetry. Order is going to be 1, 2, 3, 4, 5, 6, 7, 7, 8. 8 times that it would map, so 8 is the order. 360 divided by 8 is going to give me 45 degrees. It would have line symmetry, and it would have point symmetry because it does have a 180 match up there for rotational.